Good afternoon, ladies and gentlemen, and welcome to the second Future of Retreading and Recycling conference. You know, it's 3 years since we last did this, and you know, to be honest, I thought that this time would never come at times, but we're here today, so thank you to everybody for attending. We hope that you find what we're putting on today of interest and of good use. Thanks also to Autopromatech for hosting this event today. We're very appreciative of the efforts that they put in too. First, a couple of words, if I may, about the format of what we're going to do today. We have 6 speakers in total, 3 speaking on retreading and 3 speaking on tyre recycling. We're going to start with 3 speakers speaking for 20 minutes each on retreading, and what I'm then going to do, because we're short of time, I'm going to leave the questions until after all 3 speakers have spoken, and then if we have some time, I'll invite some questions from the floor. Then I'll invite the next 3 speakers to the stage to speak on tyre recycling. And after we're finished, we'd be happy to offer you a cocktail and something to eat outside while we set the stage up for the Recircle Awards ceremony presentation. Okay, so firstly though, I'd like to welcome to the stage Stefano Carloni, the President of AIRP, who will give a welcome address.
Allora, buon pomeriggio a tutti, sono Stefano Carloni, Presidente di AIRP e Presidente di Promotech. Ringrazio David Wilson per aver riportato ad Autopromotech questo evento, che quest'anno peraltro è anche abbinato con la premiazione del Recircle Award. Sono momenti di incontro importanti perché poi parliamo delle nostre attività che insomma che nel caso mio abbiamo proprio nel cuore. Siamo qui di nuovo a parlare, sarò brevissimo, dopo il 2019, quindi ci rivediamo dopo 3 anni, e quindi abbiamo anche modo di capire se in un triennio abbiamo fatto qualche cosa, siamo andati avanti nel campo della ricostruzione in particolare, e devo dire che non mi sembra, non siamo andati molto avanti né con la normativa sull'economia circolare né sulle normative nazionali. Nel 2019 abbiamo avuto una serie di relatori, in particolare avevamo anche un operatore importante indiano che aveva acquisito una grande azienda di ricostruzione inglese, che ci disse che aveva acquisito questa azienda di ricostruzione perché era interessato a fare il costo chilometrico. E purtroppo dobbiamo dire che dopo 20 anni di costo chilometrico, almeno in Italia, è il sistema più intelligente per rimettere del denaro, per non guadagnare, e quindi che è una cosa dal mio punto di vista anche non morale, diciamo. Quindi probabilmente non è un plus, un argomento importante per la ricostruzione. L'anno scorso, peraltro, che cosa è accaduto? È accaduto che AIRP, insieme al BPAVER, si è data da fare nell'ambito della consultazione per i prodotti sostenibili per poter fare inserire i pneumatici nell'ambito dei prodotti che devono essere obbligatoriamente progettati in ecodesign. Quindi la progettazione in ecodesign è proprio la base del nostro lavoro. Se i prodotti da nuovi vengono progettati con l'idea di poter essere ricostruiti, noi facciamo il nostro lavoro in maniera assolutamente impeccabile. Questa consultazione pubblica non ha dato esito perché addirittura tutto il mondo dell'automotive è stato posto al di fuori dell'ecodesign. Allora la domanda che io pongo a voi e mi pongo: ma noi, se cerchiamo la sostenibilità, se cerchiamo di fare organizzare un sistema di economia circolare importante, questo sistema di accelerazione delle norme e poi di frenata, perché di fatto impedisci lo sviluppo di un sistema organizzato di economia circolare, certamente non è favorevole alla ricostruzione. Quindi che cosa possiamo pensare di fare? Possiamo pensare seriamente di poter cambiare nel tempo il quadro normativo. A livello, la Francia per esempio ha fatto scuola, perché in Francia c'è un obbligo di montaggio dei pneumatici ricostruiti per le flotte pubbliche e quelli che fanno i servizi pubblici al 100%, quindi è una spinta forte all'economia circolare. Quindi noi in Italia, ma anche gli altri paesi, noi abbiamo già una norma in questo senso. Dovremmo agevolare l'utilizzazione dei pneumatici ricostruiti, intanto imponendolo, e dall'altra parte concedendo dei crediti d'imposta nel momento in cui utilizza un pneumatico ricostruito. Ma soprattutto per quello che riguarda la ricostruzione in senso lato, noi dobbiamo giungere a un rating vero delle carcasse, cioè dobbiamo poter dire con non ragionevole approssimazione ma assoluta precisione le carcasse che ci sono sul mercato, almeno dei marchi prevalenti, che tipo di punteggio hanno, e quindi quelle che sono più adatte alla ricostruzione e quelle che lo sono di meno. Sarebbe un modo estremamente corretto anche per premiare quei produttori virtuosi che spingono nell'ottica della ricostruzione e ricercano per migliorare i propri prodotti. Detto questo, vi auguro buon lavoro e sono convinto che dagli interventi che avremo potremo trarre ulteriori spunti per lo sviluppo delle nostre attività. Grazie a tutti e buon lavoro.
Okay, could I now please ask the three speakers on retreading to come and take a seat on the stage, please? That's Vittorio, Marangoni, Marco Mangialardo and David Stevens. Thank you. Please. Okay, so our first speaker needs no introduction, really. Vittorio Marangoni is the CEO of the Marangoni Group. His company has been a leading proponent of the role of the retreading industry in sustainability in terms of the tyre industry as a whole. So here now to talk about the importance of sustainability to the retreading sector is Vittorio Marangoni.
Thank you very much. So, good afternoon. Okay, I thought a lot about this title, and at a certain point I understood what was the problem. There is a mistake in this title. It is not the importance of sustainability to the retreading sector. Is the importance of retreading to the sustainability. Okay, to explain you that, I just show you some number. These are probably numbers that you know, but I think they are impressive number. It's important to look at this number again and again because they're impressive. In many industries, they told they are sustainable, they told they are circular, because they have just one of these characteristics. We have several, and we have impressive numbers. 70% of raw material saved, 65% of energy saved, 95% of CO2 emission less. Let me explain. 95% is a calculation based not just on the production process, on the difference of production process between retreading and new tire production, but considering also all the CO2 that you need to collect all the raw material and bring all the raw material to the factory to make this process. Okay, so, and that makes a very big difference because retreading is a local for local business. It's clearly, it appears very clearly how the substitution of just the tread instead of changing all the tire has a very huge impact on what you can save. But okay, let's now look at the sustainability characteristic. So first of all, environmental sustainability. Of course, retreading has a big environmental sustainability, and well, this is also because it is the first level in the waste hierarchy. So the first level, of course, is a good use of the product, so an optimized use of the product. Then the first stage that I have, the second level, the first level, let me say, in the supply chain, is retreading. So a process that allows to keep the product in the same, for the same purpose, for the same use. And this, of course, the goal of this game is try to keep all the product as much as possible in the higher level. So here there is another impressive number, but not because it's good, but because it's bad. In Europe, only 8% of the total tire are retreaded. Only 8%. So, you know, the opportunity of this business is huge. We can do much better. Economic sustainability. Okay, look at the economic sustainability for a while in a different way. So, retreading is a local for local business. That means that is mainly a short supply chain. So, most of the material needed to make retreading, it comes from local market. So this, what does it mean? You know, talking about something that is on the newspaper, it means to optimize the strategic independence from imports. It means I have to import less raw material, I have to use less energy, and so on. Just some number. In Europe, we import from Russia the 40% of synthetic rubber, the 30% of carbon black. These two makes 2/3 of the compound, of tire compound. And the rest is mainly natural rubber, which is not produced in Europe, but it came mostly from Southeast Asia. And with all the logistic issue that we have right now, is another problem. So, economic sustainability also for the system. Then, of course, there is economic sustainability for the business. And this is something that I want to explain, because if you look at the single price of a retreaded tire and you compare it with the single price of a new tire, basically a budget tire, maybe you don't see so big difference. Now the difference is growing because raw material are growing in price, but some years ago was not like that. But what you have to look is not at the price of the product. You have to look at the cost of the entire life cycle of the product. And if you make this calculation, you can see how big is the advantage of a retreadable tire. Because you can retread it more times, at least 1 time, maybe also 2 times, sometime even 3 times, talking about TBR. And this, of course, is going to give a lower life cycle cost. And is always lower than a use of disposal tire. Third element, social sustainability. So how retreading has social sustainability? This because if I sell a used disposal tire, well, maybe I have produced this tire in Europe, but mostly it's not like that, because probably it's a budget tire coming from another country, and that does mean that also the added value of producing is not in the local economy. So I just have the service of selling this tire, and it's over, because then I have to dispose it. If I think at a tire that is retreadable, it means that, okay, I produce this tire, I sell this tire, then it's my interest as a dealer, but even as the user, to keep this tire in good condition. So I will spend money for maintenance, for checking pressure, for crossing the tire, for then regroove it, then change it, then collect this tire, then bring this tire to retreading, and all over again. So in this entire life cycle that you have, there is a lot of activity, there is a lot of jobs, and there is many more added value that stay in the local economy than what, of course, happened with a use and disposal tire. So that's why retreading is the perfect circle, is the perfect example of circular economy. One important thing is that when you cure the compounds, the rubber compounds, well, this process is hardly reversible. Okay? Yes, you can produce rubber powder, you can devulcanize, you can do many things, but at the end is very difficult to obtain the same quality of raw material, of original raw material. So the quantity of material that you can push back into the production of new tire is very few, it's very low. The only way to keep the tire in the same circular economy, so to keep the tire in a process where it is used for the same purpose for which it has been designed, is through retreading. So that's why retreading is the perfect example of circular economy, and is the first loop that you have in circular economy of tire. Then, of course, there is recycling. Recycling is even very important because it allows to, give a new life to the material. But it's different because the material, when they get into recycling application, have a different destination, have a different purpose. So you get into a different cycle of economy. They does not substitute the material used for new tire. So this is a very important concept. Of course, retreading and recycling are not two models in competition. They are models, of course, that I think can have more synergy than what actually we are doing. If you think that all the retreaders in their process, they produce a lot of rubber powder for buffing process, for example, and this rubber powder is a perfect material in recycling application. So I think we can do better. We can make more synergy on that because retreading and recycling are two businesses that can work together. So now let's make a step back and take a worldwide look about retreading. So these are numbers in millions of tires, of retreaded tires, roughly. Okay, that you can have in the world. Right now we are living, of course, with pandemic issue, with logistic issue, with war issue. All these elements are pushing to a deglobalization. And deglobalization, of course, in a deglobalization process, a local for local business works better. From the other side, we have the increasing cost of raw material. So the increasing cost of raw material, of course, increase the gap that you can have, the advantage that you can have making a retreaded tire, because you are saving raw materials, so the value that you save is higher. And so, of course, all these elements are pushing, let me say, a strong, are increasing the interest in retreading, and the retreading is getting stronger than before. if you think also to another trend that started before COVID and now it's stronger than ever, that is goods are moving more and more and people is moving less and less. So that's mean, of course, more transportation, that means more trucks, that means more truck tires because truck tire is the most retreaded tire. So all these elements are giving an advantage to retreading in all the world. Is the same. Then of course you have mature markets that are more or less keeping their position. You have Asian market. China is still a market under transformation. There is this fight against overcapacity of production of new tire and the green politics from the other side. So it's still under transformation. The rest of Asia is an emerging market, so there are different dynamics like the changing from bias tire to radial tire. But if you look to the three big market, that is South America, just to give some numbers, South America, the retreading share on replacement of TBR is roughly 60%. United States, the retreading share in replacement of TBR tire is roughly 40%. And then it comes Europe. The share is only 22%. And 10 years ago, it was 35%. So again, in Europe, we have a lot to do. We have a lot to recover. We have a lot of margin to grow. So can we do better? Yes, we can do better. And we can do better, of course, promoting this very virtuous business, but also in technology. Just to give you some state-of-the-art technology. Okay, now we are able to produce bead-to-bead cold retreaded tire that has the same aspect and the same quality, if you think it also with a ring tread, the same quality of a mold cure tire. But with cold retreading, you can save more or less 30% of the energy. Then cold retreading, of course, using autoclave has also an important flexibility in the energy mix, because autoclave can work both with electricity or steam. Then there is development on the tread, so we can produce precure tread with a very low rolling resistance. That's it allows not just to have the same performance of a new tire, but you can even increase the performance. If you think that the tread in a tire is responsible for the 40% of the rolling resistance, is the single component which has the main effect on rolling resistance. So it's something where we can make the difference. Then, of course, promoting the image of retreading is very important. There is still an idea that a retreaded tire is dangerous. It is not true. It is not true. Many retreaders today make double chirography in and out as the same quality control of a new tire. And so we have to change this idea. Well, in a modern retreaded tire, I don't even call it anymore retreaded tire. I will call it new tread tire. It's a new tread tire. It's not a retreaded tire. Retreaded tire is something that came from the past. It's something new. Okay, take a look to the future. So what is going to change in the future of retreading? Of course, technology. Technology is an evolution that has an impact on every industry. But looking in the retreading industry, it has three mainstream. The first one is automation. Then there is integration, and then flexibility. Why? Automation, because especially in mature market, is very hard to find a worker. very, very hard. No one wants to do this work anymore. So this work has to be delegated to machine. Integration, because retreading is a complex process, because you need to handle many different tires, different size, different brands, different problems. And so you have to transfer this know-how that now is in the head of the worker that are going to end their career. You have to transfer this know-how into the software. And then flexibility. Flexibility because the business is changing and it requires a higher level of service. And so also the process has to be more flexible. And with that, I'm going to talk about another point in the future, in the evolution, let me say, of the business. So how they are changing the business model. Talking about circular economy, like I said before, we have to look more at the service, because of course I will not make all the margin selling just the product. I have to recover my margin also on the service, because if the product has a longer life cycle, I have to earn on the service that I can do during this life cycle. So this means that business are going, more and more in developing service. There are enabling technology like IoT, big data that helps, to make tire management. But there are also other changement in business, like of course the evolution of logistic. Logistic is evolving with intermodality. Intermodality means that truck transportation has to give flexibility to the system. So truck transportation need more services to do that, and is also switching the focus to the last mile delivery. This means also that we need to start looking again to smaller sizes of tire, like 16-inch. And let me say, why not even car tires? That's because even a new tire producer are thinking to produce tire with a better design, with more retreadability, and they are coming back on this idea even on car tire. And so this is also a business that can start again. So looking more and more in the future, what can be the evolution of the tire, where there are mainly two ways. From one side, the airless tire, where of course you can easily understand how you can retread it several times. And from the other side, this is a 3D printed biomaterial tire, but in this very futuristic concept is anyway designed the possibility to be retreaded. So whatever will be the future of the tire, there will be retreading. So with all that, what can I say? I'm still thinking that the point is not what sustainability can do for retreading, but what retreading can do for the sustainability of tire industry. Or let me say, at least we as Marangoni are going to take this challenge. Thank you.
Thank you. Okay, thank you very much, Vittorio. So we've heard about the importance of the sustainability message to the retreading industry. But it's not only the retreading industry that's saying that, it's the tyre manufacturers as well. And our next speaker is a representative of the tyre manufacturing industry. Marco Mangialardo is from Michelin, and he's going to talk to us about what the eco-design of a new tyre can do for retreading.
Okay, I'll just launch the PowerPoint, 1 second. There we go. Maybe. No. Go again. Technology, there we go. Voila. Thanks, David. Good afternoon, everyone. I'm very pleased to be here today speaking to this great crowd at this great event. It's actually my first time here at Autopromatec. I'm Marco Mangialardo, Innovation Manager for Michelin Italy. I joined the company back in 2005, and I've always been working in tire manufacturing, plants in Italy, plants worldwide. Today I'm actually based in Cuneo plant, but my mission covers the entire Michelin Italy industry, Torino, Cuneo and Alessandria. Just some data of Michelin company. Michelin is a worldwide group with roughly 125,000 employees. We are present above 170 countries, almost everywhere, and we have 70 factories all around the world. Speaking of Michelin Italy, we are the biggest tire producer in Italy. We employ 3,800 people. We have a production capacity of 14 million tires per year. 13 millions are for passenger car that we produce in our Cuneo plant. Our Cuneo plant, by the way, is one of the most important worldwide for Michelin. For sure is the biggest in Western Europe, and also the most important for innovation. Is where we develop all our processes and our new products. Another million of tires is for truck tires, truck and bus, and we produce in our Alessandria plant. We have a third plant in Torino that produce semi-finished product for the other plants. In Torino we also have our headquarters and one of the two distribution centers. The second is in the Rome area. And finally we have our marketing and sales headquarters that is based in Milan. So today I will talk about the eco-design of a tire with the focus on profitability and sustainability. This is a very important topic. It is part of Michelin sustainability strategy that I will let you actually discover about this strategy in the next video that I brought from our CEO, Mr. Florent Menegaux. I hope we should go.
My belief, our belief, is that in Michelin tomorrow, everything will be sustainable. Being sustainable is not only taking care of the environment, it's this balanced view of making profit, growing profit, engaging people, and taking care of the environment that is important.
So, as you heard from the words of our CEO, we have very ambitious targets. Carbon neutral, reduce waste, recycle, within a very clear vision. For Michelin, everything tomorrow must be sustainable. In order to achieve our vision, we developed our 4R strategy. Actually, I found some of the words that have been mentioned by Mr. Carloni and by Mr. Marangoni. We saw also some of the tires. So, speaking of for our strategy, what does it mean in Michelin? Recycle. Well, obviously recycle of our wastes, but at the same time, we are developing technologies to recover, recycle some of the product from end-of-life tires, introducing in the new tire process. Renew. We are studying new raw material coming from natural resources that can be reused. Reduce. Well, reduce actually is part of a mission today within, as an innovation manager for Michelin Italy, is to study how we can reduce the CO2 emission of our environmental footprint. But at the same time, we want to make lighter tires, so we consume less natural resources. But lighter tires means also improving rolling resistance, and at the end, we will make the vehicles producing less CO2. And last but not least, that is actually probably the key point for the retread world, is reuse art. So we want to repair our tire, regroove, retread by making our tire lasting as much as we can. So when we talk about eco-design, what do we really mean? In Michelin, it is the approach that we use for all our products. And it's a global approach. It takes into account the entire life cycle of the tire, starting from the raw material up until the end of life of the tire, so including the recycle of the tire at the end of life. But when it comes to truck tires, we have an additional challenge, that is the multi-life. So not only we have to think about the one life of the first life of the tire, we have to make sure that the technology that we input in the tire and that we make the tire reaching the performance level that we are looking for depending on the usage of the tire, will also allow the tires to be retreadable. So we allow the tires to have multi-life. So our tire designer cannot separate the concept of the new tire from the retread tire. It's a unique global design. Okay, now, especially with my past, with my expertise, I will go into some technical details, okay? So here we go, we see a tire, and we identify three key elements on a tire that are important for the tire performance: the tread pattern, the tread compound, and the casing. Tread pattern and tread compound are key elements to guarantee the performance of the tire at the level in each life of the tire. So we promise to the customer performance level, tread pattern, tread compound. These are the main elements for that. The casing is actually the element of the tire that must remain, will be remaining the same throughout the multi-life of my tire. So it is the key element for the multi-life approach. In fact, I want to give you an example of three main technologies of the casing. Obviously, we have technologies that goes in the tread, but if we speak about multi-life, eco-design, and the benefit on the multi-life approach, we have to focus on the casing. So the three technologies are Infinicoil, Duracoil, and PowerCoil. And I will tell you what are the benefits of each individual technology on the life of the tire and on the life of the casing. Voila. First one is Infinicoil. So there we go. So Infinicoil is a steel cable. It can be up to 400 meters long that is wrapped around by casing. So it kind of embrace the casing. It has a double roll. It improved the performance of the tire, like endurance, rolling resistance, the fuel consumption. How? As you can see in the image beside the video, you can see the footprint of the tire. Okay? If we imagine the steel belt that wrap my tires, this guarantees the footprint on the street, on the sole of the tire, that is going to be wider and more stable during the usage of the tire. Okay? So this also guarantees a uniform wearing of the tire. Okay? At the same time, if we think about the casing and how it will, the Infinicol technology will impact the life of the casing, we have to think about the effort, the impacts, the stress that is going through the tire during its usage. We have acceleration, deceleration, braking, steering, the load, the road hazards. I'm a cyclist, I know very well the road hazards, unfortunately. And with this belt, we will reinforce the case and we maintain the case newer and so more retreadable, because we will be less impacted by this stress. Second technology is the Duracoil technology. Voila. So with the Duracoil technology, we were able to design a new bead. I'm sure everybody is familiar, just to make sure the bead is the ring, the steel ring that is on the side of the tire that connect the tire to the wheel. Okay? So in the new bead that we designed, we were able to wrap the bead around an high technology nylon tissue. Thanks to this new type of bead, we were able to redesign the bead zone. Okay, that is the zone actually that connects the tire to the wheel. That is one of the most delicate zones of the tire. All the input coming from the wheels must be transmitted to the tire. I said before, accelerate, decelerate, steering. Okay, so it's very delicate and very stressed. Ideally, we would like to be rigid and glued to the wheel. Obviously, it's impossible. Okay. Thanks to this technology, we increase the stiffness, improving the performance, and reducing the negative aspect of this stress, of this fatigue, to the case. And once again, the case can last longer. Last technology that I want to talk to you today is power coil. Voila. So power coil is our new steel cable that are actually deep into rubber. And these are the cables that make up the casing structure. This technology has multiple positive effects on the tire. First of all, we were able to reduce the diameter of the cable. Again, reduce in terms of making our tire lighter, rolling resistance, reduce CO2 emission, etc. We eliminate the oxidation risk. Before, there was no rubber, there was air. Air is an enemy for steel. In this case, we had rubber, no more oxygen, no more oxidation. And last and very important effect on the case, in the casing last, it is the fact that we have this rubber among the cable, and all the heat dissipation is facilitated. So my casing will suffer less the stress from heating generation that we have during the usage of the tire. Voila. So I gave you 3 examples of technologies and their impact on the casing and tire performance. But what really are the figures of the eco-design approach? Some numbers. First of all, we talk about sustainability. Actually, we found some numbers that has been given by Mr. Vittorio before. If we go back to the 4R strategy and we think about reduce the raw material consumption, in a retread tires, we apply only 30% of new raw material to retreaded tire, compared to a new tire, monolife, that it's 100%. In terms of the recycle, the R for recycle, we have 50 kgs less per tire to recycle. And for our customer, it clearly improves the profitability. If we take a retread tire, we at least double the kilometer that we can run. And in terms of money, our customer can really save 40% on the cost, on the price of a tire. So, for this reason, we truly believe that eco-design approach in multi-life model, it is the best solution for a sustainable and profitable business for our end users. And that's it. Thank you very much.
Thank you. Okay, thank you very much, Marco. So if we accept that the retreading industry has a strong sustainability argument, then the key thing is how to get that message across to people. Well, our next speaker is going to talk to us about that subject. David Stevens is the Managing Director of TRIB in the United States, and he's going to talk to us about communicating the retreading industry's sustainability message. David Stevens, ladies and gentlemen.
Can someone help me with the Italian to English for slideshow? Sorry.
What do you need to do?
To do the slideshow?
Oh gosh. Can we, excuse me a second. Hello, can we have some help? Can I have somebody
Maybe this
on
one.
stage as well? Yeah, I want a full screen, yeah. He's got it, okay?
Okay.
Okay, thank you. Sorry.
Just needed to work on my Italian a little bit on PowerPoint. Thank you so much, David, for having me here. It's such a pleasure to be here with everybody. Quite honestly, it's a pleasure to be anywhere other than my house, locked down with restrictions. So, first time outside of the US in 3 years. It's a real pleasure to be here. I wanted to talk about some very specific things that we do in the US to help communicate the sustainable benefits of retreading. And before I do, just a quick, for those of you that don't know what TRIB is, we are an organization founded in 1974 our mission is a very simple one. We promote and defend the retread industry. Now, even though we're a US-based organization, about 25% of our members are outside the US. So we try and do everything we can to help lift the entire retread and repair industries by educating users, governments, legislative bodies, and even other retreaders about what's happening in the industry. And just for some of the figures I'm going to talk about later, I wanted to give some context of what's going on in the U.S. retread market in terms of size and history. So it has a long history in the U.S. We've been operating retreading since 1912. If you look at the economic support for retreading, about 270,000 direct or indirect jobs supported by the retread industry, and over $28 billion in economic value from retreading in the US. Obviously, it's very heavily weighted to truck and bus retreading. These are the number of plants that are in operation today in the US. About 650 truck and bus retread plants, 18 off-the-road construction retreading, 5 aircraft plants, and we still have a couple of passenger tire retreading plants, primarily light truck, taxi, winter tires, 4x4 enthusiast off-road operations. So there's starting to be some discussion about could we bring passenger tire retreading back in the US. Some people are looking at that, but we haven't gotten there yet. This is a look at some of the figures specifically for US truck tire replacement. So the column in green
thank you so much.
are new replacement truck and bus tires sold in the US every year. And the blue column are retreaded truck replacement tires. So you can see in 2021 we had about 16 million truck and bus retread tires sold in the US. And if we go back probably 5-10 years, that new to retread ratio was about 50-50. And with the introduction of low-cost Asian imports, that spread between the new and retread has gotten bigger. But fortunately, the retread industry has been able to hold its own in terms of pure volume. So we saw about a 10 to 15% increase in 2021 over our figures. So the retread industry in the US had a very good year last year. I think, as many of you know in this room and my colleagues have talked about, the retreading benefits have always been very visible. And in the US, it is readily apparent, and the figures display that. So US trucking fleets save over $1 billion every year by utilizing retreads in their operation. 30 to 50% less for a comparable new tire, 500% more mileage when you're using retreading in your operations. And I think this last one is one of the most interesting statistics in the US. So 87% of fleets that have 100 or more trucks are active users of retreads in their operation. So those, and it goes up and up. So if you go to a fleet that has 1,000 or more trucks, 92% of them are using retreads. And they know, because it delivers the lowest cost per mile and the lowest total cost of ownership without any degradation in performance, reliability, safety. So where we have the challenge, and this is one of the things that we're working on, is going down to those smaller to medium-sized fleets who still might have some misconceptions about retreading, or they don't have a great inventory of tires that they can use in a retreading program. So that's where we spend a little more of our effort in education. I just wanted to talk specifically about one fleet example and the impact that retreading can have. So obviously this is a decent-sized fleet in the US. In 2018, they bought 12,000 new tires, and they retreaded almost 27,000 retread tires in their operation. They worked with their retread partner and said, look, we want to increase our percentage of retreads. Let's work out how we do that in 2019, and let's see what impact we can deliver. So their partner worked with them. They reduced their new tire purchases down to about 9,000. They increased their retread usage to 34,000, so it was a 3.8 to 1 ratio of retread to new. What did that deliver? $4.2 million in savings for 1 year for that one fleet, 1.5 million kilograms of CO2 taken out of the air, 236,000 gallons of oil saved, and 18,000 tires kept out of landfill. And so that was a massive financial impact for that fleet. But I mention this because the next thing that's coming from fleets is, yes, they want to see those savings, but they want to see that quantified for their sustainable targets that they're being set. Whether by their own company or their parent corporation, they're now saying, look, we have targets that we have to hit in terms of reducing sustainability. We need to deliver a specific program that does it. We need to measure it, and it needs to go into the bonus structure, the profitability targets, all of that gets rolled into their sustainable targets. Safety and reliability. This has always come up as an issue in the US and around the world. I mentioned, since 1995, there have been 5 independent studies conducted to assess the reliability of retreaded tires. Every single one of those studies at the end of it came out and said, we should be buying more retreaded tires. So a couple of those states, like the VDOT is state of Virginia, and ADOT is the state of Arizona. And the reason they started those studies is because they wanted to ban retreaded tires. They said, but we need to have the data so we can say, look, retreads are dangerous, they're littering our highways, we want to ban them. And at the end of both of those studies, the agency said, you know what, we actually need to be buying more tires, more retreaded tires, because we're saving money for our counties and cities and states, and we're not having any performance issues. So whenever someone says to me, oh, I would never use retreads because they're not as safe or reliable, we have an entire library of studies that we can point them to. Some of the surprising places that retreads are used, and this also helps with, when we're marketing retreading in the US, if you can tell someone that, look, every single day your child goes to and from school on a retreaded tire. And that really gets them thinking about it. 80% of the commercial aircraft taking off and landing on retreaded tires. When your garbage gets picked up, it's being picked up by a truck on retreaded tires. All of the OTR, and then the enthusiast 4x4 off-road. Yeah, I learned an interesting figure or a story this past year that when 9/11 happened in the US and those New York City Fire Department trucks rushed into the World Trade Center to try and deal with the emergency that was there, they were running on retreaded tires. So if they can respond to an emergency like that on retreads, there shouldn't be any doubt about using them in any of your operations. So what we're talking about here is, we know, and these guys have talked about it, retreading is really the greenest of green industries. It starts with the casing itself, specifically designed to be retreaded multiple times. Plants themselves are sustainably operated, whether it's using solar power, capturing everything in the retreading process that ultimately gets recycled. And then the outputs, reduce carbon emissions, huge landfill avoidance. So there's no doubt about the bona fide sustainability metrics for retreading. And I think for me, this is one of the most important points for the next year, next 2 years, next 3 years. And you saw from Michelin and Marangoni, they are leading on sustainability, and it starts with the design of the tire itself. But if you're not, as a manufacturer or a retreader, leading on sustainability, you're going to get pulled into it by your trucking customers because they want it. And they have targets they have to hit. So in the US, FedEx, UPS, some of the major fleets, they have set sustainable targets that they have to hit. And they're working with their partners to figure out how they can do that. Is it more aerodynamic trucks? But a lot of them don't even think about their tires. If you just ramped up your retread usage, you would meet those targets almost overnight. So, and I think the second point is that federal, state, and local governments have their parts to play. So I'm going to talk more about a program we did in California, and it's in the governments are going to start to come in and say, look, you need to reduce your carbon emissions and figure out a way to do it. And they're going to set targets for these fleets and these companies, and retreading can help solve those problems for them. So this is I've been working for the last, 4 years to develop a program with the state of California. Because California is so forward-thinking in terms of their environmental approach, we thought we could do a test program in California and hopefully take it to other states throughout the US. So we were able to work a deal with California where we got a 2-year contract where we had $250,000 from them that we could invest in education, spending, marketing, promotion for their municipal state fleets. Our overriding objective with this program was to support their group called Cal Recycle. And CalRecycle is just 100% focused on improving recycling rates for everything, but they have an entire team that focuses just on tires. And it originally started to get tires out of landfill, but it's shifted to how do we reduce inputs at the beginning of the process. And you know, $250,000 is not a lot of money, but we also wanted to say this is a test program that we can only take, and you know, in next year maybe we can get $1 million, a $5 million grant that includes tax incentives or other things that we can do. This was to just demonstrate to the state that we could help lift the retread rates in the state and also drive more benefits for them in terms of cost savings and environmental benefits. So what did that look like? Well, first we did a lot of education and training. We surveyed the California fleets just to understand what did they know about retreading. And of course, we found out that many of them don't know anything about it, or they have a bad impression of it. So we wanted to set a baseline and understand what our education efforts might do to help lift that. They also have a program called SABRIC, which is the State Agency Buy Recycled campaign. And they're supposed to mandate a certain percentage of their purchases are supposed to be of recycled products. But what we found is there's all sorts of loopholes. So if you're a local waste fleet in a county in California and you're supposed to buy 20% retreads, they figure out all these loopholes that they don't have to do it. And so what we found is that they weren't buying many retreads because one particular fleet manager had a negative impression of it, and so he was doing what he wanted to do and got around the whole process. We developed a number of marketing materials to help educate people about retreading. We did a specific evaluation to look at light truck and passenger tire retreading because they're interested in that in California. Many of the fleet vehicles throughout the state are passenger and light truck tires, so they wanted to see if there's something we could do there. And then we looked at the environmental impact that lifting retreading in California could have. We consolidated all the safety and reliability studies so the fleet managers can have a better view of that. And we're in the process right now of developing our final recommendations to the state, including additional funding, creating some tax incentives, and creating other programs that can help pull retreading through their fleets. This is just a couple of examples of, this is a very simple 2-page brochure that went out to all of the fleet maintenance people and managers within the state of California to help them understand why they should be choosing retreads and to answer some of those questions that they may have. We filmed a brand new video called Retreads Work. So we showed people the process inside a plant. We answered the specific questions that they may have. And this is available through the California's CalRecycle's website. It's also available on TRIB's website. And so there's a lot of pointing we do to this to try and get fleet managers to understand what retreading is all about. I mean, as these guys know, and as many of you in the room know, if you take a potential fleet customer into a plant and they can see the process, that's the single best way to convert them to a customer. Because they have this belief, and I hear it at some of the trade shows that I go to, where truckers will come to me and they'll say, oh, retreading, that's where they just take a new piece of tread and they glue it on an old tire. They don't understand the technologically advanced process that retreading goes through. Once they see it, they have a greater understanding of it and they're willing to engage with it. Our original plan is that we would be doing in-person retread plant tours based upon what I just said. So we had various regions in California where we were going to go into the plants, bring in all of these local fleet people, take them through the plant, do an educational session, answer questions so they could see it. Well, you know, COVID killed all of that, so we had to shift and we moved everything virtual. So we had 7 webinars throughout the year, and where we went into those plants virtually, still did the tour, answered those questions, and then we also created a lot of opportunities. So those local, the retreader in that local area who was taking those people through their plant, they were then able to connect with that California local fleet manager to say, hey, you know, we've got the webinar done, why don't you come in, just you, and see our plant, let's talk about what we can do. So we helped create a lot of business, well, potential business for our members, but we also opened the eyes of the fleet managers within various areas of the state. And so most of we did 6 truck webinars, and then we had 1 off-the-road and construction one. And the off-the-road one was actually our best attended because there is a lot of off-the-road and construction use in California as well. We are all talking about sustainability. As an organization, TRIB is increasingly focused on that message in the marketing that we do. So we have a video that we produced that's all about the environmental benefits of retreading. All those things that we've been talking about is very clearly spelled out in that. We did a short, video to promote Earth Day and all of the impact that retreading can have for Earth Day around the world. And it's not just us pushing it out, it's prospects asking us, tell us about the environmental benefits of retreading. And I think this is also increasingly a generational thing. So there's a massive truck show in the US every year in Louisville, Kentucky, and it's called the Mid-America Truck Show. Probably the single biggest truck show in the year. And these are smaller owner-operators, generally smaller fleets that come to this to buy chrome and air conditioning units and tires. And in the past 10 years, when we would have those people come and talk to us, many of them were very negative about retreading. And I would say this is the first year where I've seen a real shift where you also have that next generation of truck drivers who are in their 20s that are, they're not taking the word of what someone older than them has said, they're educating themselves. So they would come to our booth and say, tell me about retreading. I want to understand how much I can save by doing that. I also am very concerned about the environment. So tell me about how retreading plays a part in helping with the environment and sustainability. So they were completely different discussions than we've had in previous years where it was like, retreads, never use them, never would. These guys want to know and they want to educate themselves and they're concerned about the environment. This is just that quick video. So I think you see with that video, that does not have a corporate look and feel to it. It's, it's targeted to a slightly younger demographic. It's a little more playful, but it has the specific data. And, in our marketing efforts, we're reaching out. We do a lot of social media, Twitter, LinkedIn, Facebook, Instagram. We're trying to reach users where they are today to help them find more information about retreading. And this is an example of that. And I think, and it was talked about a little bit before, but just the continued technological advancements in retreading are a huge part of sustainability. So whether it's at the beginning of the process, improved inspection, so we make sure that quality casings only go through the process of retreading, the increasing collection and integration of data, all of the information about the new tire, how many times it's been retreaded, repaired, how has it been treated. So again, we can deliver better quality products and we can keep those tires on the road longer, so that ultimately creates a better sustainability issue. Robotics, so I think this is an issue everyone is facing worldwide, but finding good people, hiring them, and then keeping them. The number of stories I've heard in the US, we finally found someone, we got them to work, we got them trained, they came in and they worked for a week and they never came back. And, they may have gone down the street to go to work in an Amazon warehouse at better pay in an air-conditioned environment instead of working in a retread plant. So, you know, many of the retreaders are looking to, well, how do we make sure that we still deliver a quality product, and are there ways that we can rely less on human capital, or find ways that we make the work easy for our easier for our workers so that they're willing to stay. These guys have talked about the airless tires, tread designs and rubber compounds, and more recycled materials going into the manufacture of new tires, and also retread rubber, so it's an important part of it. And I think there is so much discussion about electric vehicles, and especially electric trucks in the US, and what is the development that needs to happen both on the new tire side to deal with the increased weight of the batteries, the increased torque coming from those non-combustion engines, and, you know, retreading needs to be a critical component of that. And so, you know, with so much of the retread industry in the US concentrated in a few hands, it helps with the development of products that meet both the new tire side of things and the retread tire side of things. And this is just my final word on retreading. Hopefully you guys have taken all of these messages away, but, you know, retreading, if you're gonna use it, you're gonna save a ton of money. You're gonna have a massive impact on the environment, and you're gonna take advantage of the investments that are being made in new tires. It amazes me that people buy a quality new tire and then they're willing to get rid of it after one use. You know, 70% of the value of that tire is in the casing. And when people come and say that to me at trade shows, I'm like, God, you must be rich, because if you're just throwing money away if you're doing that. So take advantage of those investments that they're making. And lastly, you know, we just can keep millions of tires out of landfill if we can increase the adoption of retreading. So thank you again for hosting me. It was a real pleasure to be here. Thanks again, David. I appreciate it. Well done.
Okay, thanks very much to all our speakers. That culminates the retreading part of the conference. We are running a couple of minutes behind schedule, so what I'm going to do is I'm going to move on to the second part of the conference, which is on tyre recycling. So in the first instance, could I please thank Vittorio, Marco and David for their presentations. Thank you. And we'd now like to switch around the speakers, so if I could ask Claus and Federico to come to the stage, please. And our third speaker, Dario, is, I think he's planning a different sort of entry. So if you'd like, Dario, if you'd like to come here, you can. But if you prefer to prepare yourself for your presentation, please feel free to move over. Thanks. Okay. Yeah, well, ooh. Okay, ladies and gentlemen, our first speaker in the second session is Federico Dossena, the CEO of Italy's leading EPR scheme, Ecopneus. Federico is going to give us a market update on the Italian tyre recycling sector. So, Federico, please make your way to the microphone.
Thank you very much. Good afternoon to everybody, and thank you for inviting me to this session. What I'm going to do, I guess it will be a sort of connection between what we have heard a few minutes ago from my predecessor speakers.
I will leave this here.
And what is going to happen once the tires really reach the end of their life. So what is going to happen when the tire is going to be recycled. And particularly what we in Italy are doing with the end-of-life tires. Okay, so first of all, let me introduce our new logo. Maybe some of you have known the old Ecopneus logo. Now we have changed it in the perspective of making or giving a stronger message related to the ethics and the legality that our companies has always worked with. And of course the graphic design is also recalling about the circularity of the tires and therefore the circularity of the economy that our recycling activity is leading to. What is this history of Ecopneus? What we have done since the beginning of the existence of the society, the company? Since the beginning, we have collected more than roughly 2.5 million of tons of end-of-life tires, and constantly every year we have exceeded the legal target given by the government. And this is because we, of course, are dealing in a country in which some critical position of the end-of-life tires is facing, and therefore we feel our role is to support and give a hand and help in order to resolve the criticities which are scattered here and there in the country. So we feel our role to be really beside of the industry and trying to solve problems at any level. What we do, in fact, and how we act. Well, the Ecopneus recycling chain is made of 18 collectors, so a logistic structure which is interacting and interfering with 26,000 dealers of tire dealers, so very capillary on the territory. We are present from the Alps down to the minor islands around Sicily and Sardinia. And through 19 treatment centers, we convert the end-of-life tires either in alternative fuels or in material which can be used in other material applications. We all know, we have heard that so far it's difficult to get, Mr. Marangoni was telling, it's difficult to get recycled rubber back in the tire manufacturing, and therefore we have to find new and different applications. As I mentioned, we are scattered all over the territory, so we are really covering geographically the whole country. And through our service provider, we are fulfilling the two sectors. 52%, as a matter of fact, is given to the energy recovery, so as alternative fuel, and 48%, luckily, is addressed to other applications. We have also created these brands in order to give an orientation. So tire fuel is the material going into the energy recovery. Tire field and tire plus, the compounds which are used to prepare the ground for sports playgrounds or finished products. Let's have quickly a look on this kind of application. So the vast majority of the tire fuel goes into the cement industry. There is a connection very solid, very historical between the two industries, and it's a good advantage for the cement industry to take alternative fuel coming from tire recycling, because it is substituting the pet coke, so with a lower environmental impact and with a better calorific power compared to the coal. And in this respect, this kind of relationship continues, unfortunately, with foreigner cement industry, because in Italy we have a clear gap of acceptance of alternative fuel given by the authority, which are a little bit reluctant to give authorization for this kind of usage. On the other side, on the material recovery, there is a lot of well-consolidated usage in the sport fields, particularly in the synthetic turf, in the football fields, but many other surfaces are now have been developed among the few past years. And particularly I'm referring to playground for tennis and for paddle, which is now the emerging sport, basket, playgrounds for kids. So quite a large variety of sports surfaces in which Ecopneus is always trying to invest and put new possibility, new feature in order to improve the performances and the safety of the players on those surfaces. Please note on the top right corner the sailing application. So we are now exploring the possibility to provide surfaces for all the marine activities, because of course the rubber is providing antiscivolo, scusate, qualcuno mi aiuti con la traduzione dell'antiscivolo. They provide a grip, the right grip, even if the surface is wet, and of course the bumping capacity. Other applications are clearly into the urban furniture, so something which goes back to the road application, or the soundproofing. We all know that the rubber characteristics is to absorb and return energy at in any kind of form. So even the acoustic energy is well managed through the rubber coming from the end-of-life tires. Another sector that we are really pushing hard in these days is the application in the asphalt. The asphalt are showing how when added with rubber powder, they can extend the life by 3 or 4 times, and particularly the elasticity given to the asphalt helps in reducing the noise when the vehicles are passing over the surface. And so far we have pushed and tested already more than 600 kilometers of road with such kind of asphalts, and they are proven to be absolutely granted in terms of noise reduction, up to 5 decibel of noise reduction, and prolonging the life of the surface by between 3 and 4 times. So the asphalt application is something that we are feeling it's really worth to be explored, invested, and studied. What about the future? What about the next step? And I guess that the next speaker will be much more competent in explaining what we are going to introduce is the chemical recycling. Ecopneus is absolutely beside the study and the application of the chemical recycling, because of course in the perspective of getting back the raw material the tire is made out of, and therefore putting them again into the hands of the tire manufacturer in order to close the loop and to get really bring back the material into the manufacturing of the new tires, of course looking at the possibility to get them also retreaded several times. So this is a short view of what we are doing, what we are acting in here in Italy. And it's, of course, I'm available for any kind of questions, and if you have time and willingness, come to visit us to our stand in order to go deeper into our matters. And I'm now giving the floor to Claus for the next part. Thank you very much. Thank you.
I think you were the last, but you're the last. Yeah. Okay, so our next speaker is from Chile, Dario Andreani, who's a Chilean entrepreneur, and he's one of the country's leading retreaders also. Now, Dario also has a company called Sustrend Lab, which is a pioneering technology company who've just invented a lithium-ion battery made out of end-of-life tyres, which is really quite an innovation. Now, Dario is going to tell us all about it, but first we'd like to introduce you his little baby, who's called Tifito, and if you look at the red carpet, you'll see him.
Hello, everybody. How are you? Hello, everybody. How are you? Nice to see you here. I'm glad to introduce you Tifito. Tifito is my little friend here that is the first electric vehicle that is using batteries made from end-of-life tires. So I'm glad to be here to present you this. I'm Dario Andreani, the co-founder of Sustrend and Sustrend Lab. I'm one of the inventors of T-Fight. T-Fight is the raw material that is made from end-of-life tires to build batteries. So I want to let you know how we did this and what is this story about. So let me leave Tifito here and start my presentation. Can you help me, please? I don't want to make a mess here. Yes.
Okay.
So, like I said, my name is Dario Andreani. I'm here to present you what is the problem, which is the size of the problem, and what is the solution we developed in Chile in my laboratory to face this problem and get a solution. Why T-Fight? T-Fight is because it's an acronym in between tire and graphite. So T-Fight. T-Fight is the first graphite made from end-of-life tires on human history. How this story begins? Back in 2014, we started up Sustrend, a consultancy firm, environmental consultancy firm that their purpose was to support retreading industry in Chile. So back on those days, we did a methodology that calculates and accounts the carbon reductions of the use of a retreading tire instead of use a new tire. So with that methodology, we knocked the door of the Chilean Environmental Ministry, and they take us to be like a retreading industry into the AIRP law in Chile. So for first time in history and the first country over the world, we have inside our AIRP law a goal of retreading. After that, in 2017, we start to support the tire recycling industry in Chile. And that was our first approach to the tire recycling industry in Chile and the first step on pyrolysis plants and the first step to face this huge problem that is the recovered carbon black. So at the beginning of 2018, we discovered that we could transform recovered carbon black from a Chilean pyrolysis plant into nanomaterials. So on those days, I was here in Europe, in the Tyre, back in 2018, showing the audience how we did it. So at that point, was very amazing to see all the faces, surprised faces, seeing how we did these nanomaterials from this black powder. And at that point of my career, I realized that the problem was worldwide and huge. So at the end of that year, we won the innovation program that give us the resources to start working on a recovered carbon black solution. Having those results, in 2019, we decided to develop and build our first recycling raw materials laboratory in Chile. And we built and started up Sustrend Lab, a technological area from Sustrend, the consultancy firm. So in 2020, we won the first science startup program that gave us the funds to develop the technology until TR6 stage. And in 2021, we developed the first prototype of battery using T-Fight, this great battery graphite made from end-of-life tires. So we developed a 2032 model battery, like a button. Do you know the button batteries? That was used in clocks, in calculators, and those. Okay, we did it in our laboratories, and we tested empowering propeller. So when we realize that the battery works, we get one more step, and we build a battery that is 18650 model battery that is used on computers, scooters, TFITO, and electric vehicles like Tesla. The only difference in between them is that for TFITO you need just one battery. In your tools, Buddhist tools, you need 1 or 2 batteries, and in a Tesla car or electrical vehicle you need 7,000 batteries. So this validation in 2022 give us the opportunity to be here with you. So I would like to show you what is the problem. The problem is that each year we are generating 1 billion end-of-life tires that have not where to go. So that means is like 1.4 times the Washington, D.C. area. So from the beginning of this year until now, we already generated almost 400 billion tires. So the problem is huge. So pyrolysis plants, pyrolysis is a technology that transforms the end-of-life tires into steel, into pyrolytic oil, and into carbon black. The problem is that carbon black is no market because they're poor quality, they're poor properties. So the problem is that nobody knows how to do with that because it's no market. So we start to study it in our laboratory, and we develop this technology. We developed this technology that is the first graphitic carbon that can be used to build batteries for electromobility. It's a sustainable alternative for battery market, and it has an excellent conductivity and high performance. You have to think that with 120 PCR tires, we can do a ton of T-Fight, and that ton of T-Fight can make like 14 electro vehicles like Tesla, okay? So this technology is a great opportunity to do circular economy in the automotive industry. Why? Because with our technology, we took this recovered carbon black from the pyrolysis plant and we made it T-fied. Looks like the same, but it's much, much different, and I will show you why. So with this material T-fied, we develop ion lithium anode that is placed here. This is a copper, how can I say this? It's a copper paper, okay, with the T-fied inside. So with this, we build our batteries. These are the 18650 batteries that are used in tools, in computers, in electric vehicles. Inside the battery is the anode with our material, and it's a cathode with lithium. So both make the battery works. The thing is, from this poor material here, carbon black, we develop through a chemical technology a transformation to that battery-grade graphite that you can see on the image there. The good thing is that image is all T-fied under the microscope. And those rugosities you can see on the image give us much better properties than regular graphite. So, what is the good news? The good news are that T-fied is much better than regular graphite because we did the same efficiencies and capacities, but we did it with 75% less of emissions. So it's better with the environment. But also, we are doing valorization of up of 80 TBR tires to do electric car. So we did it cheaper, we did it faster, we did it better with the environment, and we did it much better. And I will show you why. Our technology, the current stage is TRL6, which means that it's working. In the first image here, you can see the T-fied that is under the microscope. Then we transform to build a battery, and with the battery, this year we start to produce modules of batteries to do testings on electric vehicles, on different devices. So on our testings, in our laboratories, we did this exercise. We established the baseline of the capacity of a battery made with recovered carbon black. So we took the recovered carbon black and we built a battery like this. And we start to test it in our tester, in our laboratory. And we can see there that the capacity of the recovered carbon black is very low. It's under the 100 milliampere hour by grain. So with that baseline, we start to test batteries using commercial graphite. That is the white line there, okay? So the commercial graphite has a technical capacity of 372 milliampere hour by grain. For our surprise, our T-fied is much better than that. You can see there a small amount of difference in between one material and the other one, but for a battery, it's really, really much. We are having results of about 400 milliampere hour by grain. That is much, so much. And the other thing that is amazing that we discover over the testing is that if you look at a regular battery, when you start to charge and discharge, and doing all the cycles, over the time, the capacity start to go down. Finally, you can use it anymore. Instead of that, with T-Fight, what's happening is when the cycles start to go over, the material improve their capacities. So, surprise, our material becomes better than regular graphite. So, recovered carbon black has around 80 milliampere hour by gram, like a capacity. The graphite, commercial graphite, has 372. And T-Fight is having, until now, 400 milliamperes. So it's so much. What is the business opportunity here that we see? Since 2018 to 2024, the growth of the graphite market is 60% annual. So that means $92 billion each year. So if you look for 1 million electric vehicle, you need around 3,000 tons of graphite. That today, you can obtain it by two ways. One is the natural one, that is mining a carbon mine to get the graphite. And the second one is to do it in a laboratory in a synthetic way using huge amounts of energy. So this is a very sustainable alternative to supply the battery industry with a much less carbon footprint, with less cost, and much better. So I want to introduce you my team here. They are a very, very young team. I am the older man here. So these are the guys that are doing all the job. And I'm very, very, very happy and proud of them because they are doing a lot of effort. I thank them a lot because all the commitment they have. And wait a minute. And I want to let you know that this was a long process. Hours of effort, not just from me, but also by this great team. We are committed to understand the tire life cycle like a whole, like the people before me told, and I'm very happy because I start to see the life cycle of the tire like a whole from many years ago when nobody talked about this. And for me, it's very happy and very exciting to hear today big people like Michelin, like Marangoni, like all the big players on this industry talking about circular economy, talking about sustainability, because it's the way. It's the way. We are going that way for many years ago, and see that this is happening today is very, very happy for us because we really are convicted that that is the way. I never thought when my dad take me to my factory, my retreading factory to play with tires, that I will be involved in a project like this. We are showing to the world today that science and business can go together in order to make this place a better place for future generations. And we are not going to stop. We are recycling one tire at a time. Thank you for listening.
Okay, so we're now moving on to the final presentation of the evening. We're going to talk this time about pyrolysis. And our speaker is Claus. He's from the consultancy company Weibold. and he's going to talk to us about the opportunities that exist within the tyre pyrolysis sector. Thanks.
So, good afternoon, everybody. Right here. Claus, that's me. Five. Presentazione. It must be. So great. Thanks for the opportunity to introduce you. Let's say I want to give you a very high level overview over chemical recycling of end-of-life tires. Sometimes it sounds very trivial and easy, but it's not. That a lot of entrepreneurs learned in the past that it's tough, to produce recovered carbon black. Anyway, I don't want to go too much into details today, and especially not too much into the technical details. Maybe in the beginning, I just give you a short, the disclaimer, please don't copy, and so on. Who is Weibold? Weibold is an international consulting company. We are specialized exclusively on tire recycling and end-of-life tire pyrolysis, so the chemical recycling path. Weibold was founded in 1999 by Robert Weibold. Is headquartered in Vienna in Austria, and we have offices around the world in Argentina, Bahrain, India, Mexico, Morocco, and Spain. So you find us everywhere where you need us. Our clients are basically or mainly recycling and pyrolysis project owners and initiators, of course, operators, investors, banks, technology suppliers, and last but not least, recycling associations around the world, whom we are allowed to consult. So the problem is already known. We heard it a couple of times. I want to keep it short. Around 30 million tons of end-of-life tires arise every year worldwide. There's very, very sad news in it is that approximately 10 million tons out of these 30 million tons are practically not known where they are going to. So landfill dumped somewhere in your private stockpile, in the garage, and so on and so on. The European Union is primus inter pares, is very good in recycling and collecting tires. 3.5 million tons of tires are collected every year. Are rising every year. Out of this 90%, at least 90% are collected. And now 50% out of this 3.5 million tons are recycled. There are many paths. We don't want to discuss now mechanical recycling, yes or no, versus chemical recycling. I want to point you to the 40% energy, meaning practically that 40% out of these 3.5 million tons arising every year in the European Union is combusted. I say it very simple, it's burned. It's a so-called waste-to-energy recycling path. We could discuss about that very, very long. I don't want to do it now. We only say it's practically a destructive, even though you are producing energy, it's a destructive recovery or recycling path because the resources are gone. Once you have energy and then poof, that's finished. So therefore, we see as a consulting company together with most of our clients, by the way, a potential for sustainable recovered material to produce or to recover sustainable recovered material at about 1.5 million tons per year. But how to do that? How we get that back? It was mentioned already a couple of times today. It's chemical recycling. Chemical recycling or pyrolysis is maturing. It was a long way to go until now. It started already the first trials in the 2000, beginning of the 2000s, with Chinese technologies and so on. We don't want to discuss that. We are not speaking about the most simplest technology. We are speaking about nowadays about state-of-the-art technology, which is running successfully already in Europe. We will speak about that a little bit later. The most important thing for me, at Weibold, I'm also responsible for writing this Academy article series in our monthly newsletter. I found out that it's of utmost importance that we find a common definition. And thanks to the European Chemical Agency, we have now one. It's pretty simple. Pyrolysis is an irreversible chemical decomposition caused solely by a rise in temperature. We see that on the right side. And most importantly, in an inert atmosphere. What means inert atmosphere? Nothing else than there should not be any oxygen, no air. We need no air. We need a temperature higher than 470, let's say 500 degrees Celsius, and we need time. It's the same like you are baking your cake or baking your something in the oven in the kitchen. Now, it's practically the same reactions are running in there. So we see then on the next slide a little bit more about how the steps are running in the pyrolysis. Let's only look at this definition here. I found it very, very interesting because it's not from us. It's from the European Chemical Agency. It's a European agency. What they say is a rule. Pyrolysis of waste rubber and I just quoted here, and end-of-life tires is a chemical recycling operation by which waste materials, so the end-of-life tires, are reprocessed into chemical products like recovered carbon black and tire-derived pyrolysis oil to become, and that's very important, become input feedstock for chemical plants and other industries. And therefore, chemical recyclers are both. On one hand, they are waste managers, and on the other hand, they are manufacturers of new substances in the sense of the circular economy. That's not from me, that's a quote from European Chemical Agency, published in last year only. So let's see in some steps what I am speaking here about. You have this end-of-life tire. You cannot retread it, you cannot do anything else, you dump it practically. No more use. So the first step in the chemical recycling is you have to reach a status of high quality feedstock, and for that you have to cut the tire, you have to shred it, you have to granulate it. You have practically the first step in any chemical state-of-the-art chemical recycling part is a mechanical recycling. You take out the steel as much as possible. Nowadays you make it up to 95, 97%. Take out the steel, you take out the textile fibers, and then you sell them. It's recycling, mechanical recycling. The granules is the feedstock for the pyrolysis operation. A pyrolysis plant consists of a reactor, an oven, a reactor which is heated, nothing else practically. So if you heat these granules, the chemical reaction or the heat is decomposing the long chain molecule in the rubber. Yeah? The organic cut it in more little pieces. And those little pieces are flying like a vapor, an oily vapor. You take them out of the reactor, you condense them, practically you don't do anything else, and you cool it, and you liquefy this gas, this vapor gas, and the result at the end is the so-called tire-derived pyrolysis oil. It's very, very similar to crude oil, and it's you can totally mix it with crude oil, but, and that's the trend, it's not a diesel, it's not a substitute for diesel, it's not a substitute for any petrol or fuel in the first row. We will see that it is a substitute for the chemical industry to use it or to substitute petrol-derived feedstocks. And that's the way how it goes in the circle. We will see that a little later. But the good thing is that not all this vapor, not all this oily gas can be condensed. There remains a part which is not liquefying. It's the so-called permanent pyrolysis gas. And this accounting approximately 10% of the feedstock mass. And this 10%, that you use as a fuel to produce the energy which you need to heat the reactor. And I can tell you in advance, probably you know it already, a state-of-the-art pyrolysis plant or pyrolysis operation is self-energy, self-sufficient in the core process. That's important to know. So, something remains because not everything is decomposable. The second important product stream is the so-called carbon black or recovered carbon black, which is not only consisting of all the carbon blacks which were originally in the tire rubber, but also the silica. You have in the recovered carbon black, of course, silica, the metal oxides, the additives. They are remaining somewhere because you cannot decompose it, and they are the so-called ash in the ash content in the recovered carbon black. So just a quick look, you know that a tire consists of 50% rubber, synthetic and natural, carbon black, silica, 20% accounting, 10% additives, I mentioned it, and this 20% steel and textile. And again, only a chemical reaction is able to decompose the organic content of a tire. The rubber, synthetic or natural, and taking with him the silica, the carbon black, and the additives. So the result in the output is always in between 40 to 50% pyrolysis oil, 30 to 40% recovered carbon black. Again, here, I very often hear, that's impossible. First you say 20% carbon black is in the original tire. Now you are creating 40% recovered carbon black. Hocus pocus, how you are doing that? Of course not. Yeah? Don't forget, the feedstock consists of only 80% of the tire weight. Yeah? So because we have the steel and the fibers we are putting away mechanically, then you have only 80%. And when you take out 30 to 40% carbon black, we call it recovered carbon black, but it consists only of 80% original carbons plus this 20% additives like silica, zinc oxide, mainly silica and zinc oxide, and some other metal oxide. But these two product streams, they are reprocessed and they are becoming feedstock for the tire and rubber industry. I hear pretty often, oh, you are cooking here rubber and that's not environmentally friendly, and by the way, you are heating it, and oh, how bad, yeah. So I understand this critical question, but at the end they are not really valid. Yeah? There are not a lot of studies until now about the life cycle analysis. Only one. I show you here the result. It's made in 2010 from Professor Li in China, and there he was comparing various treatment methods and found out that pyrolysis is the best one, the most environmentally friendly. Why? How can you read that? Everything what is down is positive for the environment, so everything what shows down is positive. Everything what is up, so in the positive area, is negative for the environment. So you have to think it other than in your balance sheet. Yeah? There are, of course, minimal impact, logically, because you are utilizing this gas, this 5 to 10% gas, that it's like you start an engine, you have this flue gas, that's a fact. But on the other hand, you have exorbitant environmental saving, and especially in regard to the resource saving. So only to make it, you can compare it with the Sustainable Development Goals of the United Nations and so on. It really helps to reduce to enhance the resource efficiency, to make the technology cleaner and environmentally sounding, and so on. So here we can have studies over studies. I think that I don't want to waste your time with that. And huge companies like Michelin, even Ecopneus, Bridgestone, and BASF, and all these, if you look on their websites, nowadays it's pretty easy to find their arguments, and they are all of them are pro this chemical recycling route. So it's very important nowadays to have environmental certification. So you know that end-of-life tires are waste. Yeah? That's a fact. Yeah? So you are handling waste. You are a waste manager. After you process them in a chemical recycling plant, you are manufacturer of a new product, of new chemical substances. Where is the border? And the borderline is defined in the Waste Framework Directive, saying the end of waste status. Yeah? Big discussions in Europe, in the Commission about that. Where is the end of waste status? Yeah? And one of the kickers, to get close to receive an end of waste certificate are the sustainability certificates. And at the end, all the major pyrolysis operator like Reoil just in examples, yeah. Reoil in Poland, New Energy in Hungary, Pyrum in Germany, and Restec in Taiwan and Thailand, and Boulder Industries in the US. They are all certificated already. Let's have a quick look on the trend and opportunities. There's a very high demand for recovered carbon black, and I see already an upcoming competition in between all the possible uses. Yeah, on the one hand, pardon, I didn't have my cigarette, so that's why. No smokers here. It's impossible. There's a very high demand for RCP by the tire manufacturers. Only giving you the example here, the joint support by Bridgestone and Michelin together. That what they want is they want high capacities in constant quality. We are not speaking about so much about this 20% ash which is in the recovered carbon black. That's already proven. Yeah, you can change the recipes a little bit, and that's okay. Up to 40% you can exchange. Up to 40% in a blend, you can use a high quality recovered carbon black, which always consists of 20% ash. Yeah? You cannot say hocus pocus and go away. It's here. And the silica and the metal oxides are pretty good binded to the carbon in the recovered carbon black. Anyway, they say, deliver high quantities, we need high quantities, we need a constant quality. Not the worst, but a constant quality. So that's, and of course some product standards. But they are on the way already with the ASTM D36 Commission for recovered carbon black. So here's, it's going on. On the other hand, the rubber and the carbon black industry has another high demand for recovered carbon black. I mean, recovered carbon black is in fact already long ago, let's say 3, 4, 5 years ago, they reached into the industrial practice. Yeah, I will show you an example a little bit later, and it's proven that you can blend recovered carbon black with virgin carbon black up to 40% share. So there's a not very optimistic forecast for the demand of recovered carbon black globally, issued by Notch Consulting. I mean, Paul Eater is probably the top expert on forecasting carbon black demand and knowing the carbon black market, and he's forecasting that 2025 around 400,000 tons of recovered carbon black demand will be given in the global market, and double of that, so 800,000 tons in 2030. We think it's not very optimistic, yeah, but we are far away, yeah, from reaching 800,000 tons per year in a high and constant quality of carbon black. So still a way to go. Pyrolysis oil is waking up, not because of the fuel demand in general, but because the chemical industry is driving the demand. On first place, BASF, if we are speaking from the European market, BASF is demanding or targeting to buy approximately, only in Europe, approximately 100,000 tons of TDO, also tire-derived oil, per year. Nowadays, there are only 2 examples here because they are publicly known. Yeah, there are others too. New Energy in Hungary is delivering the pyrolysis oil to BASF, and Pyrom in Germany is delivering. But those 2 together, yeah, plus the third one, which we know, let's say 10,000 tons per year, what they can deliver now. And the demand is 100,000 tons. So pretty an opportunity. The Black Cycle project is another demand-driving project. It's Black Cycle, probably heard it already. It is the target to substitute the fossil carbon black feedstock. The dirty, very heavy oil, yeah, but you have to well it, you have to take it from somewhere. So to substitute that with tire-derived oil. This is an European-wide project funded by the European Union, and it's running very, very positive, very positive. It's under the management, let's say, of Michelin and Orion. Orion is a huge carbon black producer, it's a virgin carbon black producer, and they are taking the oil for the trials from Pyrom in Germany. Their target, let's say, from the Black Cycle project is to take these 1.7 million tons of end-of-life tires away from the energy market, and to chemical recycling it to produce this oil, and the result would be 700,000 tons per year, yeah, and they could take it. So there will be also here is some kind of competition coming up, yeah? And the pyrolysis industry is running. Yeah? They are overwhelmed by requests. Yeah? So the trends and driving forces, I think we can go fast over this point because you know them. The consumer awareness about the environmental issues are increasing, therefore we are sitting here. There's an ample supply of waste tires around the world. I think there's no discussion about that. An increasing, so with this consumer awareness combines an increasing demand for recovered material, and most importantly, there are hundreds of millions of euros or dollars, however you want, coming online for this kind of projects. Yeah? Not only in the European community, maybe driven even by the new taxonomy regulation. You can read some articles on our website about that, and new standards are coming up. The opportunities, and the first sentence is probably the most important one, and my last one. The chemical recycling or pyrolysis in Europe and elsewhere, so even in Taiwan and in the USA, they are proven, they are matured, there are even proven business models, and maybe the most important thing, if somebody invests in a partnership with the Hungarians or with the German pyrolysis plant, then they have guaranteed offtake for the oil and for the recovered carbon black, of course, too. So that means that there's a huge support coming up by the big industry. They are jumping into the game. They jumped already in the game. Michelin is, show you only some example. Continental will jointly supply RCP and CP blacks together with Boulder Industry. Birla Carbon develops together with Circtec the biggest single largest RCP plant in Europe, 100,000 tons per year. Michelin is known, is invested in Enviro, in the Swedish Scandinavian Enviro System is the company name. It's a Swedish company. BASF, we know already, they are even shareholder in Pyrum in Germany, but they have an off-take contract with New Energy in Hungary. By the way, that was not easy for them. New Energy started in 2005. 2005 is probably the oldest existing pyrolysis plant in Europe. Started in 2005, and BASF made a very in-depth technical due diligence, of course. They succeeded, the same with Pyrum. And, oh, sorry, I am already finished. Here are some more examples. In Austrian, one Semperit is buying already over years from Rio the carbon black. Patagonia buys from, and so on and so on. So we have pages of that. The summary is, so, where is the summary? Here we have. So that everything already said. So nothing new. And I thank you for your patience. Bye-bye. Thank you.
Well, that concludes the tyre recycling section of the conference. If anybody has got any questions at all for any of the speakers in any of the sessions today, please feel free to ask them the questions outside in the area out there where we're serving some drinks in a moment. We now need to prepare this room for the Recircle Awards ceremony, which will take place in half an hour. So please stay for that. And please join us for something to drink and something to eat, and we'll see you back in here in half an hour. Many, many thanks for attending today. Thank you.